Okay, real quick about the rule of 72. Just a reminder to make sure you have this on your study sheet. Okay, and what is the rule of 72? What is that? That's estimation tool to figure out the doubling time. This is the most popular. Okay, this one is the most popular. So make sure you have rule of 72 on your study sheet and have this formula as well as this one. But if they ask for doubling time, you should have doubling time next to this one. Okay, so you can sometimes make estimations based on that. Okay, and we'll talk more about that as time goes by. But doubling time. Just a quick example. I don't know if you've used up this space right here, but let's say that your interest rate, okay, is let's say 10%, and you have $2,000 invested. Okay, and so the question might say, use the rule of 72 to figure out. Let me just do this math here. When you have $16,000, use the rule of 72 to estimate how long it would take you to have $16,000 using the rule of 72. This is how you would start this. The time based on this interest rate will be 72 divided by 10. And that is what? 7.2 years to double your money at 10%, all right? That's what you figured out using the rule of 72. But we're not done yet. We want to know how long would it take us to have $16,000, correct? So write this down. How long until you have $16,000? And it's very strategic. It's very, like that number is, you will see that it will appear if you do this right. So you do what you've done in exponential functions, because remember, compound interest is exponential growth. Okay, so time and money. So under these circumstances, at time 0, we've got $2,000. And this is going to double a bunch of times. So if you times that by 2, you end up with 4,000 after how many years? 7.2 years, right? You doubled your money. Another 7.2 years go by. What are you at now? 14.4, right? You double what you had again. Another 7.2 years go by. What are we at now? 21.6, right? If you're wondering what's happening on this side, it's I add 7.2 every time. And so what is the 8,000 turns into 16,000. And there is your answer, but you're not done yet, right? You would obviously want to do a statement, but it would take you approximately 21.6 years to go from 2,000 to 16,000 using the rule of 72 as our estimation tool. You can do this very easily. If you find any interest rate, go 72 divided by that interest rate. Now you know how long it will take for your money to double. Okay? So if you had a 7% interest rate, which is not hard to get. I will try to make a lesson where I show you how to actually do this. It's not part of the class, but I think you need to know how to actually open accounts, how to invest. I really want to take the time to do that. If this had been 7%, right, it would take you 10 years to double. So a bit more, but about 10 years to double, right? So at 7%, every 10 years you're doubling your money. So that another thing that to watch out is you want to therefore start higher, right? Start at a higher amount, because then your doubling is going to go faster. What this is not taking into account? What normally happens when you invest along the way? Do you just let it sit, or do you put more money in as you go along? Most people should be putting money in every month, right? Or every 2 weeks. That's not factored into this. This is just if you have $2,000 and you let it sit and it doubles on its own. That's what this is doing, okay? Let's, I asked you to watch 20, page 20 and fill that in. I'm gonna skip that for now, and then I asked you to work all the way to 26. 26 has some rule of 72. And I'm gonna stop there at this, this is exactly what we just did here, in case you're wondering. So how long would it take $750 to grow to $12,000 with this interest rate? You are essentially using the rule of 72. Let me just do, I'm just gonna go a random question. 26B, who did 26B already? Like if the whole class raises their hand at this point, then I would say let's skip it. Page 26, question B. Try that right now. You're going to use the estimation tool, rule of 72, on page 26, B, and figure out how long will it take for this investment to get to 10,000 using the rule of 72. I just grabbed a random example so that you have a chance to try this one more time before we do the TDM solver. So noisy today, but page 23, 5B, that's compound interest, and see if you have that on your study sheet to help you out with that, or else you have to go get the formula a couple pages back. It is what it is, so here we go. So in this case, the doubling time using the rule of 72. So make sure when it says rule of 72, you know what's, like you should immediately know what's expected of you. This gives you 11.08 years. If they ever ask, we're on page 26, Paul. Andre, sorry. Andre. This is how long it takes to double. So you just set up a chart like this. At time 0, you've got 2,500. After 11.08 years go by, you've got double of what you had before. Another 11.0 gets you to 22.16, at which point you reach the goal that you were after. So I'm going to underline this and just say that it will take 22.16 years, and time can be stated in decimals, so it's right, because you could figure out days, you could figure out hours, all of that. So it's okay to have $10,000 in the bank. This is an estimation tool, okay? Turn around. If you wanted to use the compound interest formula, I will do this because it reviews compound interest real quick. Let's see how much we would actually have, okay? Our principal is 2,500. You should copy this down just so you know how does this compare. Like, this is an estimation tool. This is the actual way you would find out. However, questions that force you to use the rule of 72 would not have compounding periods there. I did give you the compounding periods. Compounded annually means that n is equal to 1. Okay, it's happening once a year. So we would go 1, right? 1 plus the rate is, you got to turn that into a decimal, okay? Divided by 1, because n is just 1. And then this would be n times, and we're talking, x is our years, okay? Because we don't know how long this would take. 1x. Say what? How would you use that to figure it out? Actually, okay, I was going to give this a twist, Well, let's put the 22.16 in there. Or should I do it the other way? There's two things I want you to see. Since I'm going to use the compound interest formula later on, let's use this here. Let's just clean that up a bit. 2,500. This is just 0.065, right? Because you divide it by 1. Add 1 to it. You end up with 1.065. 1x is just x. Does this look like an exponential to you? Yeah. Let's type that into our y1. This is to review exponential, right? So 2,500, 1.065. Is this growing or decreasing? Growing because b is bigger than 1. To the power of x. And let's graph it. My window happens to see this. If yours doesn't see it, you need to make sure your window, your max is well over 2,500, your Y max. We can actually want $10,000, right? So we're going to go $12,000 because remember, A is my Y, this is my Y variable, right? The amount of money you have is along the Y here. So how would we find out how long it will take to have $10,000? Y2 is equal to 10,000. It's right here where that's going to happen. Second trace 5, enter, enter, enter. How long does it actually take based on this? You can't see that. 22.01 years. That's decent, right? That's fairly close to what we want. So this is just to verify that what we did is actually happening. So we let y2 is equal to 10,000. You go second trace 5, and the time is 22.01 years. Okay, this is actually using technology, but this is what I want you to do here. Okay, estimation. Estimate using the rule of 72. Anyways, I think we've done enough here. Let's go backwards to page 23. And I asked you to try A. Did I say B? I said B. So we'll do B. Determine the accumulated amount, the future value. What letter is future value? It is A, right? And the interest amount, as well as the rate of return for each of the following. So this is just review for you. This is just for you. Okay? Compound interest formula looks like this. You need to make sure you have this on your study sheet and you know what's what. Okay? So we wanna know if we invest 150,000, my interest rate is 0.0315. So just take that divided by 100. And what is N in this case? Compounded quarterly. You should have on your study sheet what that is. I think this one is fairly easy to tell that it's 4. It's 4 times a year that interest is calculated. So you have to divide your interest rate in 4, and then you're going to add that to 1 later on. This is N times T, and it's 25 years. Make sure that is in years. Your time has to be in years. If not, you have to take extra steps to make that happen. And I'll show you on my calculator how I do this one more time, because I know that on Thursday we kind of rushed a little bit. So I clean this up. I go 0.0315. Divided by 4, right? That's what I get, don't round, plus 1 gives me that. If at this point you want to already do the rest, that's fine, but I will take my time here, there's no rush. 4 times 25 is 100. So what does the 100 represent, folks? Look at this, we multiplied quarterly, right, times 25 years. So over the 25 years, the bank will have calculated the interest how many times? 100 times. Okay, that's what this is saying. So we're going to raise this thing to the power of 100, which gives us that. Okay, so it's 150,000 times 2.1911 and so forth. So this is effectively saying that you're going to more than double your money. You will have more than doubled your money at that. So now I go times 150,000. And so I have 328,668 and 85 cents. If you have $200,000 by the time you are 30, if that's how much you have saved up, and you have a 5 to 7% interest rate, you're going to be rich when you retire. I will show you that later on. Okay. I would even say if you have $100,000 by the time you are 30, you're going to do all right for retirement. You're going to have a pretty good amount sitting there. We'll do that. Yes, Sean? Question? Did you have a question about this? If you have one, let me know, okay? I'll talk to you later. Anyways, what about, this is what I need you to understand. So most students are just fine doing this. Plug in and go, right? Plug in and go. But what if it's asking you for interest? How much interest did you earn? You will go future value. They call it future value because you're calculating how much you will have down the road, minus the principal. So this is the most basic concept in finance. You take what you have at the end and you subtract what? The amount you started with. Right? 150,000. And that gives you $178,000 that you earned without moving a finger. I mean, maybe when you had to click to say invest, right? But other than that, you earned this, okay? The 150, and they put 178 on top of that for just having it sit there. At 3.15, that's actually a pretty low interest rate. So all you have, how much of what you have at the end was interest, okay? And now the rate of return, because it does ask for rate of return here. Rate of return is what? What you've earned divided by what you started with times 100. So 178, 668, 85. All these formulas I gave you before. Okay. Times 100. And that gives you 119.11%. So the rate of return depends on how long you've had it in there for, what the interest rate is, compounding periods, so forth. Let me see if you remember this. Let me see if the weekend wiped everything from your brain. If everything else is the same, what's better, to have a compounded weekly or compounded daily? Which one is better? Daily, right? A lot of you are saying daily. The more compounding periods, the better, okay? The more compounding a year, that is, the better. Because there's 365 versus weekly would be 52. Bi-weekly would be 26, okay? So you need to understand that. Which one is linear? What kind of interest results in a linear value over time? Raver, say it a bit louder. Simple interest, that's right. Versus compound, it is what kind of growth? Exponential. Is it always better to go compound versus simple interest? Is it always better? No. Sometimes it's not. Okay? So I don't know where else to put this, but sometimes watch this. Just watch and learn, okay? Sometimes you may start with $1,000 at simple interest, and you might start with $500 compound interest, and it will do this. So some time will go by where you're better off doing the simple interest investment, but then there's a sweet spot where you surpass simple interest, right? So in general, compound interest is your friend, Okay, that's the one you want to pick in general. But sometimes we do trick you and we want to see if you know what you're doing. All right, we're done here. Now we're going to do TVM solver.